All right, in this explainer, we're going to pull back the curtain on your Python code and take a look at the fundamental language of the computer itself. It's the language Python uses to talk directly to the hardware, and by the end of this, you'll be able to speak it too. Now, I know what you're thinking. That sounds a little crazy, right? I mean, our machines are so complex, we've got high-level languages, all these frameworks, and apps that do incredible things. But what happens if you strip all of that away? What are you really left with?
Yep, that's it. At the absolute core, every single piece of data, every instruction, it's just a sequence of on and off switches. We just represent them with ones and zeros. This is binary, the true native tongue of your machine.
So what if you could just bypass all those layers of abstraction and manipulate those ones and zeros yourself? Well, guess what? With Python's bitwise operators, you absolutely can. And this isn't just some niche trick for experts. It's a seriously powerful and frankly elegant way to write some incredibly efficient code. Okay, let's dive into this. When you use a bitwise operator in Python, the very first thing that happens is that the numbers you're using get converted into their binary form. So you're not really working with the number 10. You're working with its blueprint, 1010. It's a completely different way of thinking about numbers. So, here's the crucial point. These are not your typical math operators, like plus or minus. Nope. These tools go one level deeper. They take two integers, flip them into binary, and then perform an operation on each pair of corresponding bits, one by one. Let's start with the big three. Think of these as the fundamental building blocks of all digital logic, and they're all about comparing two bits at a time. We've got AND, OR, and XOR.
First up is the AND operator, which is just a single ampersand. I love this analogy for it, the perfectionist. It is super strict. It looks at two bits, and only if the first bit is a 1 and the second bit is a 1 will it give you a 1 back. Anything less than absolute perfection, you get a 0.
And this truth table just lays it all out perfectly. You can see right here, the only way to get a 1 in that final column is if both A and B are 1. Every other combination fails the perfectionist test and boom, results in a 0.
So, let's see this thing in action. Let's say we want to compute 10 and 4. First thing, Python converts them to binary. So the number 10 becomes 1010, and the number 4 becomes 0100. Now we're ready to compare them. We just go column by column, from right to left, applying our perfectionist rule. So in the first column, 0 and 0 gives us 0. Second column, 1 and 0, nope, that's a 0. Third, 0 and 1, still 0. And finally, 1 and 0 is also 0. Not a single column met that strict criteria.
And there you have it. The final binary result is just 0000, which when you convert it back to a decimal number is, well, just 0. And that's our answer. 10 and 4 equals 0. Next up, we have the OR operator. That's the pipe symbol. This one is the complete opposite of AND. If AND was the perfectionist, OR is the easygoing one. It looks at two bits and basically says, hey, as long as at least one of you is a 1, I'm happy. The result will be a 1. It's much more relaxed.
And then we have this really interesting one, XOR, the little caret symbol. It stands for exclusive OR. Let's call this one the exclusive one. It only cares about one thing, difference. It returns a 1 only if the two bits it's comparing are different from each other.
Now, those first three operators, they all need to compare two numbers to work. But the bitwise NOT operator, the little tilde, is different. It's a lone wolf. It only works on a single number. And its job? Super simple, to flip every single bit. Because it only acts on one thing, it's called a unary operator. It just takes a number, converts it to binary, and then inverts everything. Every single 0 becomes a 1, and every single 1 becomes a 0. This result has a technical name. It's called the ones complement of the number.
Okay, now this is where things can get a little tricky. In Python, the result of not 10 is actually negative 11. I know, it seems strange, but it's all because of how computers represent negative numbers, using a system called 2's complement. In that system, the flipped bits, when you interpret them as a signed number, end up being negative. It's a deep topic for sure, but the key takeaway is that NOT gives you negative x plus 1.
All right, let's talk about a real pro move, bit shifting. This is where bitwise operators go from being a kind of neat logical puzzle to a seriously practical tool for high-performance computing. And here's the key idea, and this quote from Geeks for Geeks just nails it. Shifting bits to the left is a super fast way to multiply by powers of 2, and shifting to the right is a super fast way to divide. Why? Because you're working right at the bit level. These operations are often way faster than traditional math.
I mean, just look at this. On the left, we've got our standard multiplication. 5 times 2 equals 10. Simple enough. But on the right, we have the bitwise equivalent. 5, left shifted by 1, also equals 10. You get the exact same result, but it's potentially a much faster calculation for the CPU to handle.
Now, what's really interesting about this slide is how you can see it happening. The binary for 5 is 0101. When we left shift by 1, we literally just push every single bit one position over to the left. Then that empty spot on the right, we just fill it in with a 0. And that new bit pattern, 1010, well, that's the binary for the number 10. Pretty cool, right?
So, just to sum it up, you've got the left shift operator, which is your go-to for blazingly fast multiplication by 2, 4, 8, and so on. And you have the right shift operator, which does the exact opposite, giving you incredibly efficient division.
So, okay, we've looked at logic gates, we've flipped bits, we've shifted for speed, but why does any of this low-level stuff really matter? Well, it's huge in graphics programming for things like manipulating colors, it's used in cryptography for encrypting data, and even in network protocols for packing information as efficiently as possible. Anywhere that performance and direct control over data are critical, bitwise operators are absolutely essential. It's all about control and efficiency.
And this level of control is so fundamental that Python even lets you redefine what these operators do for your own custom data types. It's called operator overloading. You can actually give this low-level language your own high-level meaning, which makes your code both super efficient and really expressive at the same time.
So we've pulled back the curtain and learned the secret language of the machine. These operators give you a direct line to the ones and zeros. They really are the fundamental building blocks. So the only question left is, now that you know the language, what are you going to build with it?